Hi everyone, my name is Murad. In this video, I'll walk you through how you can submit runs to Polyaxon. We're going to use Polyaxon CLI to submit runs based on local code. This is very good for running a rapid experimentation. We're going to also use the CLI to submit runs based on remote repos. And finally, we'll see how the UI can be used as well to submit runs. So the first thing that we need to do is check that Polyaxon CLI is installed. You can check as well that the CLI is authenticated. Finally, we can see the list of projects visible to this user. This is a Polyaxon agent connected to our cloud control plane. So I have my local folder here. The next thing that I want to do is initialize the local folder with my project. This is similar to creating a project and initializing at the same time with Polyaxon project create minus name and then passing init. So what it does basically is that it creates a local cache. So we can see here that we have a local cache created for us. And the CLI will resolve all the necessary information based on this cache. You can also see that we have 2 YAML files and 1 Python file. So we have 1 YAML file that will be used for running operation based on local code, which will require uploading the code folder. And the second YAML is going to be used for running operation based on a remote Git repo. So now we can start our first operation based on our local YAML file. First argument minus f is for passing the path of the Polyaxon file that we want to run. Minus u or minus upload is for uploading the local folder before starting the operation. And minus l basically tells the CLI to start streaming the logs as soon as the operation is running. For minus u, you can use also minus u2 or minus u from, basically minus upload from and minus upload to specify the path where you want to upload the code from or where you want to upload the artifact to. So I'm going to hit run. And we can see that Polyaxon starts a new run. It says that the operation was created, and right after that, it shows us where we can see this operation. It also tells us that the CLI uploaded the current folder here, was created, and it was compiled, and then it went from warning to running, and then it starts streaming the logs. If I hit stop here, it will not stop the operation. It only stops the logs from streaming to my local machine. The operation is running on the Kubernetes cluster that you provision for deploying the agents. So if I do again Polyaxon ops logs, it will bring the logs again. You can also do Polyaxon ops logs minus a or minus all and show all the logs from all the containers running in our operation. In fact, Polyaxon creates some additional containers to perform some initialization. So you can with minus all minus a, you can bring all this information. So we saw briefly that Polyaxon showed some statuses. You can do Polyaxon ops statuses, and it will show us the timeline. If we want to keep watching the changes in our statuses, we can just pass minus w or minus watch. So now we have our operation running. You can see that we are not passing the ID of the run or the project name. And the reason why is because we have the local cache here. So if you do Polyaxon ops get, it will bring the information about this run. You can see that this run has a description, it has some inputs, it has some settings information and some additional information. So we can also do the following thing. So this is the ID of the operation. We can do minus uid and pass in the ID of the run. So now we can go and see this operation on the dashboard. We can run Polyaxon ops dashboard. It will show us a prompt. I'm just going to say no. And just to show you that you can do minus y and then open, and this will open the dashboard automatically without the prompts. So now we can see similar information that we just saw here on the CLI, but on the UI. So we have the name of the operation. We have some description, for example, here. And I have the name of the project, the creator, which agent was used. In this case, it's the default agent with the default queue, minimal timeline for the operation. So it was created, when it was created, when it was last updated, and when it started. So we have also like a version. Basically, Polyaxon keeps a snapshot of the version of the YAML file that was created. We can see here if it was used for some other runs. We can see here some information about the input, some outputs. You can see it here. Let me enlarge the sidebar. So we saw the timeline on the UI. We can see similar information here on the UI. So the operation was created, compiled, queued, and then went to the agent scheduled, starting. So we have some warning. If the warning does not disappear and the operation does not run, you can just click on the status and it will show you some extra information. If you need to actually inspect the operation with more information about what's going on, you can just go here to the inspection. If you're running a multi-replica service or a distributed run, you can just check which pod you want to inspect. The next thing is the logs. This is similar to the logs that we saw on the CLI as well. It's also streaming to the UI. You can pause the stream to perform some checks if you want, and you can resume the stream anytime you want. So basically, you have all the information required to perform, for example, searches. So let's check if there is, like, for example, Google. So it's bringing some information from our TensorFlow. So if we do this, for example, if we enable the case sensitivity mode, it will not show us any information. You can use also a regex mode. If you are doing a search, by default, Polyaxon will restrict the log lines, but you can disable this behavior and only show a marker next to the log lines where there is a search hit. You will always have here the number of log lines with the search query in it and the total amount of logs. In the sidebar here, we have the date of those logs. You can change that format. This is very useful. For example, if you want to copy, for instance, some log lines and you want that format. You can go full screen, scroll up or scroll down, or download the logs. And you can also like show all the logs like -a from all containers. Similar to the CLI, you can enable the container name as well as the pod if you're run a distributed run operation. You can even show the node. So the next thing is the dashboard. We're not gonna go deeper here because we are gonna have a video specific for the dashboard, but you can see if your operation is logging some artifacts or metrics, it will show here. We're gonna go back to this dashboard later. The artifacts is the view where you can see all the artifacts that went in or out of the operation. We have like a full rendering engine here to show you, like, for example, this is the YAML file. We did not use it yet, but this is the file that we used. It was uploaded because we passed the -u. This is the model.py that we are using here, which basically is training a keras model. We are using Polyaxon tracking system to track some information about the data sets, as well as tracking the metrics that we saw in the dashboard. You can also see here that this dashboard has some outputs. It has a model, and you can actually render the model as well. So Polyaxon has so many rendering utils based on the formats. So even for the metrics, you can also like see them here quickly. So we can see here that we only have like 3 points. So if you go back to the metrics, we can see that basically we have three values. The resources page shows you information about the CPU load, memory, and GPU, if you have any GPU of your operation. So the shell allows you to perform any type of debugging that you want to do inside the container running in the operation. You can just click connect. Actually, it's using this command, but you can pass any command. For example, if I want to stop this and run Python, it will bring us to a Python. But this is basically like the same as doing bash and then doing Python. So you can see that I'm having access to basically the same thing as in a normal Python shell. The next tab is the lineage. You have like information about the metadata inputs and outputs. But you also have like information about the artifacts. So in this case, we have an upload. We're going to go back to the lineage of the next operation to show you like how different runs can have different type of lineage. So we are also logging some information during our run. You can show all the lineage here. You can also filter. And we also have some outputs. We are logging some metrics. We can show the statistics here about the metrics that we are logging, but also we have a tensor board and we are logging a model. So all this information is tracked with Polyaxon. Finally, this is the Polyaxon file that we are running. You can see the CLI here, and it shows you that you can run commands without passing any arguments. But if we didn't have a cache, we will have to pass the project as well as the operation, basically, ID. Okay, I'm going to go back now to my CLI, and I'm going to run a different operation. I'm going to use typed file.yaml. So now we can see that the YAML is not valid. And the reason why it's not valid is because we have a required inputs. It actually says that here in the error message, we have the Polyaxon file has non-optional inputs and outputs. So you need to pass a valid parameters. So I'm going to do Polyaxon run -f typed YAML -p. This is a capital P, not lowercase p. So and a lowercase p is a project, uppercase p or -params is for passing parameters. So I'm going to pass the epochs. So it says now that it created the run. In fact, I did not pass -l, so I can run Polyaxon logs if I want to show the logs. As soon as the operation starts running, it will start streaming the logs. So we can go also to the dashboard here. So now we are going to open the dashboard for this operation. You can see as well that it was created. It has a different component state. If we go back to the info here, you can see that it has a different component version state. If we go now to the Polyaxon file, you can see it's quite large. And this is where the split view comes into play. It shows us the operation, how we pass the parameters, for example, the epochs. And this is actually the component and how it was specifying the inputs and the outputs. In fact, this is the input that we are passing the value for epochs, and it's not optional. So we can hide this information here. I can see how we are passing, again, the values from the inputs and outputs to our command. There are multiple ways how you can pass these parameters to your programs. You can use them as arguments, but you can also pass them directly as environment variables. So if you go to the compiled operation, you can see that everything is actually resolved and injected in our compiled operation. So the last thing that I want to show here for this video is the lineage of the information between this operation, which is showing us that there is an upload, and these operations where we are running code based on the git commit. So if I click on this, it will show us the git commit that we used here. So if we go back here, we have all the information about these commits. So we are using the default Polyaxon quick start, and this is the commit, this is the branch. So that's the difference between running code based on our local repo or remote repo. You can combine the two, or you can even use multiple repos in the same operation. Polyaxon is quite flexible, and it performs a lot of work basically. So if we go here in the logs and show all containers, bring the containers, you can see here there's a container initializer that comes from Polyaxon that will clone your repo. So if we do run this operation, this very same operation, because it's based on a remote repo using the UI, you can just click here, new job, and pass this. So we have the epochs required. We can either pass it as a parameter, but since I'm passing this value manually, I can just do this. And I can do one, create, and it will create a new run. You can see that this run is now queued and then running as soon as the agent picks the work. So if we go here, you can see that it already changed to running. So it depends on how busy your agent or your queue is. We're going to see how the queues work in a future video.